Welcome! Do you want to learn English in a fun and easy way? In this video, we teach English using narrated, animated stories. Here is how it works. On the left, watch the beautiful animations. They are designed to help you understand and enjoy the story. On the right, you can read along as you listen to the narrator. When we reach a difficult word, don't worry. A box will appear at the bottom with a simple definition and an example to help you learn. Let's get started.
This is the story of Iceland, a small country that made a huge change. It went from needing a lot of oil from other places to using clean energy from its own land. This change was big. Iceland became a strong leader in using green energy. It transformed from a nation that depended on imported oil to a powerhouse of green energy. In the cold winter of 1973, the world faced a big problem. Countries that produced oil stopped selling it. Because of this, the price of oil went up very high. For Iceland, this was a very bad situation. The island nation had no oil of its own. Many homes used this imported oil to stay warm. People faced a terrible choice: freeze in the winter cold, or for the country to go bankrupt. The government had to pay a lot of money to help families heat their homes. The country was in a very difficult spot. Iceland has only about 370,000 people. It is a small and isolated place. But these people found a secret power source. This power was hidden deep under the ground. Most of the world did not know about this special power, or they simply ignored it. This secret energy would change Iceland forever. By using this underground power, Iceland has transformed. Today, it gets almost all its electricity from clean sources. Nearly every home is heated naturally. This means people pay some of the lowest energy prices. The country even has surplus power, which helps bring big companies to the island. How did a small country, far away in the North Atlantic, find this amazing energy? How did they learn to use it? The answer to their survival was buried many miles beneath their feet. This source of power was always there, but to use it, they had to awaken a sleeping giant. This meant digging deep into the earth, into a powerful, hidden force. It was a risky step. This book will tell you how they did it and what it means for everyone. The island nation had to tap into this immense power, which was both a gift and a challenge. 2. The Land of Fire. Iceland is a special island with amazing land. Its ground is very active. This is because of its unique geology, the study of what the Earth is made of. Imagine the Earth's surface as a giant puzzle. This puzzle has many big pieces called tectonic plates. Two of these huge plates, the North American plate and the Eurasian plate, meet under the Atlantic Ocean. These two plates are slowly moving away from each other. This movement creates a long underwater mountain range called the Mid-Atlantic Ridge. Iceland is located right on top of this ridge. This means that on Iceland, you can actually see the two huge plates pulling apart on land. For example, at Thingvellir National Park, visitors can literally walk in the deep cracks where the Earth's surface is separating. This makes Iceland the only inhabited island in the world where these tectonic plates are visible on dry land. But Iceland's special geography doesn't stop there. It also sits over what is called a mantle hotspot. Think of this as a strong column of superheated rock that comes up from very deep inside the Earth, like a heater from below. So Iceland has a rare double feature. It's being pulled apart by the plates and heated from underneath by this hotspot at the same time. This creates a place with lots of volcanic activity, hot springs, and earthquakes. This active land means Iceland is home to more than 200 volcanoes and over 600 hot springs. There are also more than 20 large steam fields where temperatures reach over 150 degrees Celsius, some even reaching 250 degrees Celsius. Rain and snowmelt water go down through the rocks and get superheated by the magma, then rise back towards the surface. This constant cycle provides vast, endless heat just below the ground. This heat is not limited by sunshine or wind, and it doesn't depend on oil from other countries. This unique geological setup, like sitting on a time bomb of heat, actually saves Iceland's economy. The constant heat allows them to warm homes and produce electricity without needing imported fuels. It is a powerful source of energy that comes directly from the earth. However, living on top of so much fire also brings hidden dangers. The same forces that give Iceland its energy can also cause problems. Volcanic eruptions and strong earthquakes are a real part of life. These explosive events can change the landscape and threaten towns. While this explosive geography creates endless heat for Iceland, these dangers are always present, just beginning to surface in everyday life. 3. Hot water and strong rivers. Iceland's energy system stands on two strong pillars. These two sources make the country a world leader in clean energy. The first is geothermal heat. This energy comes directly from the hot ground beneath Iceland. The Earth's inner heat warms water that flows deep underground. This water gets very hot, sometimes reaching 250 degrees Celsius, before rising back towards the surface. When you turn on your tap in Reykjavik, hot water comes out, sometimes smelling a little like sulfur. This is the Earth's natural heat working for you, not a problem with the water. This hot water heats 90% of all homes across Iceland, warms the many public swimming pools that are an important part of Icelandic life, and even melts snow from city pavements in winter. It also helps special greenhouses grow fresh vegetables all year round, even in the cold Arctic region. This means families get very cheap heating, almost for free. About half of all the main energy used in Iceland comes from this geothermal source, which does not depend on sunshine, wind, or the changing international oil market. The second pillar is hydroelectric power. Iceland is a land shaped by massive glaciers. As these large ice masses slowly melt, they create strong, fast-flowing rivers. These powerful rivers tumble down from Iceland's high central lands towards the coast with enormous force. Combined with the country's regular rainfall, this creates perfect conditions for making electricity from water. Icelanders have learned to use this natural force. They build special power stations that capture the energy of the moving water to make electricity. More than 70% of Iceland's electricity comes from these glacial rivers, with the remaining 30% produced from geothermal power. Together, these two natural wonders give Iceland a 100% green electricity grid. This means all the electricity on the national grid comes from a mix of heat from underground and power from melting ice. 85% of all the country's total primary energy comes from these homegrown, clean sources. Only a small amount of fossil fuels is used, mainly for cars, fishing boats, and a few small, faraway islands not connected to the main power lines. This abundance of clean energy means Iceland has some of the lowest electricity prices in Europe. However, this success brought a new, unexpected issue. Iceland quickly found itself with a surplus of energy. They made much more electricity than their people could ever use, but because Iceland is an island far out in the ocean, it could not easily sell this extra power to other countries. There were no large power lines connecting it to mainland Europe. This geographic isolation, which once made Iceland weak and dependent on imported oil, now contained its energy within its borders. This led to a very strange problem. What could the country do with all this extra green power? The big oil problem. In October of 1973, a big problem hit the world. Countries that produced oil stopped selling it to many other nations. Suddenly, the price of crude oil went up by 70%. For many big countries, this was a shock, a hard reminder of how fragile global energy could be. But for Iceland, a small island in the North Atlantic with no oil of its own, it was much worse. It was a serious existential crisis. At that time, about half of all homes in Iceland used imported fossil fuels for heating. When oil prices tripled quickly, ordinary families faced a terrible choice. They could not afford to keep warm during the long, dark Arctic winters. People felt the panic of possibly freezing. The government was forced to subsidize the oil, but the country's money was still in great danger. Iceland, isolated at the edge of the Arctic Circle, had nowhere to hide from this problem. Instead of trying to buy more oil from other countries, Iceland's leaders made a bold choice. They decided to look downward into their own ground. The National Energy Authority had already been studying the hot power beneath the country's surface. Now, suddenly, there was strong political will and urgent financial need to act on these studies. What they did next was smart and brave. The government and local energy companies began to use old equipment in a new way. They took oil drilling rigs and changed them. Instead of looking for crude oil, they repurposed them to find hot water deep underground. They used the tools that had served the old energy system to build a completely new one. A special national energy fund was created. This fund offered loans to help cities and private groups pay for the first drilling and exploration costs. This lowered the financial risk for those willing to invest in the big change. The results were extraordinary. This whole countrywide effort led to an amazing transformation. In just 12 years, from 1973 to 1985, Iceland almost stopped using oil for heating homes. The amount of oil used dropped sharply, from 50% of all heating to only 5%. This rapid change involved cooperation between the state, cities, towns, and private companies. Reykjavik quickly led the way, building and expanding a large system to send hot geothermal water to almost every house. By the late 1970s, nearly all homes in the capital were connected to geothermal district heating. This success was not just because of Iceland's unique geology, it was also because of good governance. All political parties agreed on the goal. There was patient, long-term public investment in new infrastructure. They also created ways for families to connect to the new geothermal network without high upfront costs. Iceland, a small island nation, had fought back against global oil giants and achieved the impossible. But the powerful new energy systems and machinery they built would soon attract some of the biggest companies on Earth. Big computers and factories. After Iceland had successfully switched to green energy, it faced a new situation. It produced much more clean electricity than its small population could ever use. However, because Iceland is an island far away in the North Atlantic, it could not easily sell this extra power to other countries. There were no long underwater cables to carry the electricity. This unique challenge led Iceland to a smart solution. Instead of trying to export the energy, it decided to attract big industries that needed a lot of power. These energy-hungry companies would come to Iceland and use the surplus energy right there. This way, Iceland could make its abundant green power valuable. One of the first types of heavy industry to arrive was for aluminum smelting. Making aluminum requires an enormous, continuous supply of electricity. Global companies like Alcoa and Rio Tinto built massive factories in Iceland, drawn by the promise of very low electricity costs, often just a fraction of what they would pay in other parts of Europe. Today, Iceland produces about 2% of the world's aluminum, providing significant economic growth and jobs for its people. Later, another major sector began to emerge: data centers. These are large buildings filled with powerful computers called servers. Servers require two main things: reliable electricity and constant cooling to prevent overheating. Iceland is an ideal location for both. Its electricity is 100% green, coming from geothermal and hydropower, and it is also very cheap and dependable. Crucially, the island's cool Arctic climate allows these servers to be cooled naturally with outdoor air for most of the year. This free cooling means data centers in Iceland use far less energy for cooling than those in warmer places, which saves a lot of money. Companies such as Verne Global have established large server facilities on the island. They often highlight their use of 100% renewable energy. This is a strong selling point, helping these companies demonstrate good environmental credentials and meet growing demands for reducing carbon footprints. For a period, the energy used for mining digital currencies like Bitcoin in Iceland even surpassed the electricity consumed by all of Iceland's households combined, showing just how much extra power the country had. While the initial boom in cryptocurrency has slowed, the demand for data centers continues to increase. This is partly driven by the ever-growing need for advanced computing power, especially for technologies like artificial intelligence. The modern world's appetite for computing power seems endless. This constant and rising demand pushes scientists in Iceland to explore even more extreme and powerful energy sources for the future. 6. Drilling into deep fire. Iceland is always looking for new ways to get energy. The ground below is full of heat, but scientists want to go even deeper to find even more powerful sources. They started an important research program called the Iceland Deep Drilling Project, or IDDP. Its main goal is to find a special kind of water deep underground that can provide much more energy than before. This project aims to unlock a new level of power from the Earth itself. In 2009, the first big drill, IDDP-1, was working in a place called Krafla in northeast Iceland. Engineers were drilling much deeper than usual, hoping to reach very hot water. But something surprising and dangerous happened. At about 2.1 kilometers deep, the drill accidentally hit melted rock called magma. This was a big surprise for the team and a truly high-stakes moment. The temperature there was an incredible 452 degrees Celsius, glowing with intense heat.
Even though it was an accident, this event taught scientists a lot. The well became the hottest in the world.
It produced superheated steam with enough power to generate 35 megawatts of electricity. This showed that even unexpected events could reveal new ways to get energy, pushing the limits of what was thought possible. Later, a second project, IDDP-2, began on the Reykjanes Peninsula. This time, the drilling went even deeper, reaching 4.65 kilometers. Here, they found what they were hoping for: supercritical water. Supercritical water is very different from normal water. At extremely high temperatures and pressures, it acts like both a liquid and a gas at the same time. This unique state allows it to carry much more energy than regular steam or hot water. Experts believe that a single well tapping into supercritical conditions could produce as much electricity as 10 regular geothermal wells. This would be a huge technological leap. It could make geothermal energy much cheaper and more powerful around the globe. This means that even countries far from active volcanic zones could potentially use the Earth's deep heat if they can drill deep enough. The implications for global energy production are enormous. However, controlling this kind of intense power is extremely challenging. The underground conditions are very harsh, and the drilling equipment must be strong enough to withstand such high heat and pressure without breaking down. Scientists are working hard to find safe methods to harness this deep fire.
If they succeed in controlling this powerful underground energy without destroying their tools, the way the world gets its energy could change forever. This project is exploring a new era of power, offering a glimpse into a future where energy is truly abundant. 7. Turning bad air into stone. Iceland's unique land offers more than just heat and water. The special volcanic rock beneath the island, called basalt, can take in carbon dioxide and change it into stone. This amazing process is used by a project called CarbFix. It helps to turn dangerous air into something safe and solid. The CarbFix project works by first capturing CO2 from geothermal steam, which is a key source of carbon pollution. This captured CO2 gas is then mixed with a lot of water. This makes a kind of fizzy water, much like soda water you might drink. After this, the fizzy water is injected deep underground into the layers of basalt rock. Since 2015, more than 70,000 tons of carbon dioxide have been injected this way. Once underground, the CO2 starts to react with the basalt rock. Through a natural process called mineralization, the carbon dioxide turns into solid minerals, or stone. This transformation happens much faster than scientists first expected, taking only about 2 short years. Once it is safely trapped in rock, the carbon cannot escape back out and into the air. This way, dangerous carbon pollution is permanently turned into stone.
Companies like Climeworks have partnered with CarbFix to build direct air capture plants in Iceland. These machines are designed to pull CO2 directly out of the atmosphere. These plants, named Orca, and a bigger one planned called Mammoth, need a lot of energy to run. However, in Iceland, they use clean, green geothermal electricity. This makes the entire process of carbon removal effectively renewable, showing how Iceland uses its energy abundance in new ways. This method offers great hope for our planet. It shows a way to actively fight climate change by taking carbon out of the air, not just slowing down its release. It is like reversing a harmful process directly.
This small island might hold the key to truly making bad air good again. But as these machines pump huge amounts of gas deep into the earth, local residents are starting to ask important questions about what happens next and the long-term effects on their land. The future of power. Iceland's journey shows a country making a big transformation in its energy use. From relying on imported oil, it moved to clean power from its own land. This led to energy independence. But even with much green energy, there are limits for the future. One big limit is Iceland's glaciers. These huge ice formations feed rivers, vital for hydropower. Global warming melts these glaciers quickly. While this gives more river water now, experts predict glacial runoff will lessen in 40-50 years.
This means less hydropower as glaciers shrink, so even unlimited energy is affected by global climate change. Living on a volcanic island also brings dangers. Volcanoes erupt sometimes, threatening towns and power stations, forcing evacuations. Earthquakes are common and can change underground water flows, affecting geothermal systems. So the planet's heat brings energy, but also risks. Also, growing cities near Reykjavik stress geothermal fields. Over-extraction can deplete resources, even if they seem endless. Still, Iceland's story offers important lessons for the world. It shows that countries can change energy systems fast with strong political will and cooperation. Iceland chose to invest in its own domestic power sources instead of maintaining dependence on costly imports. Many countries have sun, wind, or underground heat they could harness better. Iceland's example proves clean energy brings wide benefits. It made energy cheaper for families and created new jobs. The first reason for this change was not the environment, but economic stability. Good environmental consequences came later. This pragmatic way shows green energy can solve many problems together. Not every country can replicate Iceland's unique geology, but the lessons of smart, long-term policy choices, teamwork, and brave investment in local resources can be copied.
Iceland is an existence proof, a real example that a clean energy future is possible and can happen faster than expected when conditions and will are strong. What do you think other countries can learn most from Iceland's energy journey, considering its unique geology and its political choices?
Hey there! Just a second before you go. If you learned something new today, please give this video a like, write your thoughts in the comments, and subscribe to the channel. It only takes a second, and it really, really helps to create even better English videos for you. Your support means the world. Thank you.